So in this video, we're going to go over the very basics of terminologies in our details, as well as what every line represents and what each object is at the very basic level for our standard detail conditions. So we're going to start with just some basic terminologies. So we'll start with these details here. So this is our typical Inviso corner mullion. It's also referred to as a chevron mullion or an arrow mullion. So those are terms you may have heard, and they're all referring to the same thing. And this is Inviso, which means there's no aluminum surface covering the glass. So that means the glass is visible, which means it's Inviso. The next one here is a captured jamb. So it's a jamb because there's no glass on the other side, and it's the perimeter of the window system. It's a jamb up against the perimeter material. This is our captured intermediate mullion, our intermediate vertical, male and female. It's made up of two parts, or it's just called the vertical. You have a male and female. The male is always on the left side, and the female is always on the right, and that is due to the way we install our units, always from left to right. This is an Inviso male and female, or intermediate vertical. Same thing, it's left to right. Male is on the left, female on the right. And it's Inviso because there's no aluminum surface covering the glass. You can see the difference of a captured versus Inviso. Okay. Horizontally, it's very similar. You have a captured horizontal. Excuse me. This is the captured face covering the glass. This would be an Inviso vertical, horizontal. This would be a captured sill. And then this piece is what we call our sill track or sill runner, some people call it. That gets installed first in the field, and then this sill member is part of the actual unit that's built in the shop. Okay, so that's the very basic terminologies. So now we're just going to go over some more in depth of what's in the details. So we're going to just jump right here to the intermediates. So on the vertical details, you have these screws, which we call our assembly screws. These screws are drill flexes that have a washer head on them. So I wanted to show you what that image looks like. So they have a silicone washer. So this allows us to be able to use this as a watertight connection assembly screw without having to put any sealant over the fastener head. So that's why we have this extra little cyan piece here that's representing the washer. Now we use that typically, that is our standard, that's the 13 VP. But you'll see at our corners, we do not use that fastener, we use a 13 HP. Since it does not have that washer, we thus have to caulk over these screws here. The reason we use this 13 HP is because at corners it's typically a higher load, and the 13 HP is stronger than the 13 BP. So that's why you'll see the corners have a different fastener as well as sealant in this front cavity. This front cavity in front of these legs on all of our parts is considered a wet area. Thus, anything in that area needs to be caulked over. We are allowing water to get into the system up to that point, and we do not want any water to get past that point. So you'll see that's why we have these gaskets here, and then at our sills, those gaskets align with these gaskets. So this whole area in the front is a wet area, and that's why everything needs to be sealed in front. Excuse me. Anything behind is considered a dry area. Okay, so those are assembly screws. In order to use the assembly screws and attach the horizontal pieces to the verticals, we need to have access. So we need access holes. So on the jambs, we have these access holes shown with a notch, and then we plug them with a silicone plug to help hide the holes as well as plug it so no air comes through after the screws get installed. At the male and female, we have access, but here, because there's this aluminum wall here, we need to have access holes for the shop to be able to get their drill bit in and install these fasteners. So I have our little ISO here to kind of show you what I'm talking about. And so this web of the vertical extrusion gets in the way of the drill bit getting to this wall here. So they have to drill access holes into this vertical members to allow us to screw into these horizontal members. Where these screws actually bind in horizontally is what we call our screw raceways, and that's on all of our extrusions. And that's why horizontally you see just the tip of the fastener, because it's virtually coming at you, and so we're seeing the ends of the screw tips. Okay, so that's the assembly screws and access holes. The next thing I wanted to go over is the glazing pocket. So where the glass goes is considered the glazing pocket. The back of pocket is the edge of the cavity where the glass fits in, on the closest to the interior. So back of pocket is this line here, and that should align on all our systems, the back of pocket. Okay, so horizontally it would be this edge here is considered the back of pocket. Okay, where the glass passes the edge of the vertical member and goes past the part into the pocket, that's considered the glass bite. So that's literally what's holding the glass in place, is from this edge to the edge of the glass. That's the bite. Okay, we use structural sealant to hold the glass in place, so that's what you're seeing here. This is our standard. You can see, though, at the jams, when it's captured, we do not use structural seal. Okay, but in Viso and captured verts, we use structural seal. Horizontally, it is not sealed, but at the Invisos, it is sealed, because that's what's holding the glass in place. Okay. Behind the glass in our verticals, these are called back gaskets. So these literally are like spacer gaskets, also is another term. It's creating a space from the metal to the glass. And imagine these glass pieces are getting installed laying flat on top of a table. So these spacer gaskets are pretty dense, and they help hold up the glass this set distance until this sealant cures in the shop. Okay. The gasket in the front is considered a wedge gasket. It's a little softer, and it's literally pushed into place this way after the glass is installed. Okay, here this has a little wiper, and this is again based on the design of how this gets installed. In this captured verticals, these pieces get installed this way, so a wedge gasket would not work. So they use these wiper gaskets, and they have them pushed inside this plate or this extrusion. So when the shop installs it, it all comes together at once in this motion, and then those wipers literally compress. So that's why we have a different design here than at the captured jams. On Invisos, this is called an Inviso spacer gasket. And so what it does is it compresses once the units get pushed together horizontally, and then it's supposed to mimic a caulk joint. So it should bow in as if it were sealant. Okay, but this is our Inviso spacer, and it's always attached to the male. That's our standard. The gaskets in the back are considered air gaskets because, again, this area is dry, so they're not protecting from any water, but they're just protecting from any air not flowing right through and creating some kind of whistling sound. Okay, so at the sills, we have, again, an air gasket in the back. We have this rod, aluminum rod, which only occurs at the verticals. This literally helps with installation, as well as putting some pressure up against this gasket in the front, which is where we don't want water to be able to come up through. So it helps create the pressure equalization, as well as helps us defend this water line. Another terminology for you is this sill track. This is considered what we call the chicken head. You may have heard that quite a bit. So again, this is critical to our water line of the system. This dashed line is a splice leaf. Only happens at the splice locations. Okay, horizontally we have a couple new pieces here. This block, which is what the glass sits on, is called a setting block. Those are only 6 inches or 4 inches long, and they are only at the quarter points of a unit. Each piece of glass needs 2 setting blocks. On our Inviso, it's just a nice rectangle represented here. And this is what we call a setting chair, which helps support it. And again, these only occur at quarter points. It's not continuous pieces. And here we don't use a gasket between the glass, we actually use sealant. Okay, so that's the basic terminologies that I feel I can go over with you at the moment. And so the next video will go over what the lines and detailing of those lines represent.